Since this tutorial focuses on DP Micress post-processing, some general information about this tool shall be given. As already mentioned, it is a post-processing tool for 2D, which can be downloaded from the Micress website for free. It runs both under Linux and Windows and generates images, data analysis, and data format conversion. Last but not least, it enables operations on datasets. Currently, an example of post-processing using Display Micress will be presented. After the installation of the DP Micress program, which is available on the Micress website for free, the corresponding icon appears on the desktop. Beginning with DP Micress, the user simply needs to click on the DP Micress icon shown on the desktop. By clicking on it, the program opens and the Micress main window appears. To begin with the presenting of the available applications DP Micress has to offer, first I select a result file, here growth pinning press corn.mcr, which will be treated in the following. I just drag and drop it onto DP Micress and the graphical user interface of DP Micress opens. There is also the possibility to open two result files at once. Here I choose two files and again drag and drop them to DP Micress, so that both are opened in the graphical user interface next to each other. Starting from now, I will pass through all applications DP Micress has to offer by using one single result file. The result file which will be treated is again the growth pinning press corn file. While treating this file, the tools and functions will be explained step by step. So let us have an introduction to all basic functions. Firstly, we have the taskbar, which enables all the functions to modify the active result file. These functions will be presented in a more detailed way in a minute. To simplify operability, there's also a so-called quick start bar, which you can see here below the taskbar, which contains some central, frequently used applications of the taskbar. So when dealing with the quick start bar options, first of all, the time settings are explained, which you see here on the left. And there are basically three central tools to take a look at the specifically desired animation. So firstly, the whole simulation can be watched fluently from the first step to the last step of the animation, just by clicking on that button. Here, the value of the time increments is 10 seconds. Secondly, there is the option to switch to the start point of the simulation or to the end point of the simulation. Thirdly, by clicking on those two buttons, it is possible to move forward and backwards in time to the previous or to the next steps. A fourth option is you can manually select the time values and enter them directly. The coordinate system can be chosen here. 3D datasets can only be displayed in 2D axis parallel slides. So XZ, XY, and YZ define the visible dimensions, and the reference unit is the position in the third dimension. The 2D can be done by selecting the coordinate system together with its reference unit. In the following, the 4 mouse pointer tools shall be presented. First of all, there's the zooming tool, which allows a closer observation of certain areas by clicking and moving the cursor in any direction. The zooming can be cancelled out by clicking once. Furthermore, it is possible to move the visible zoomed-in area afterwards by holding the CTRL key while dragging. So if we zoom in and want to move the area, just by holding CTRL, we can move this area. If having moved the area as well, a double-clicking reverses the selection. Furthermore, there is the rectangle drawer, which enables a change in scaling and also makes use of these values for the color scales, minimum and maximum values. So if we draw a rectangle, the color scale is changing as well. A simple clicking reactivates the automatic settings of the color scale. Then the Points and Lines tool reveals the properties of one single point in a label. When adding another point, the 2 points are automatically connected by a line. This line generates a direct comparison by seeing the distance between the 2 points. If a third line is added, there's also the angle between 2 lines revealed. This link can also be moved by changing the point's position, and by clicking twice on a certain point it will be removed, and analogously the connected line. A double clicking on a line removes the point-line combination, and when removing a line which lies in the middle between 2 other lines, the 2 related lines at the 2 ends are connected to each other automatically. The anchor gives a reference value to another point. One click places the anchor, and to define the anchor's position, it can be moved to a desired point. Beyond, by clicking on the arrowhead, the anchor's target position can still be changed. A double-clicking on the arrowhead activates a popping-up window which comprises several designing opportunities and moreover the possibility of deleting the arrow. A Micress results file can be opened with dp-micress, which can be both a new data file by Open Solution or a beforehand used one by Load Recent. The simulation results can be saved in several data formats for other usages. For example, by the Export Group as Image tool. There are several formats available. The TIFF format is especially recommendable when dealing with uncompressed files, but this format consumes also a lot of storage space because of the high quality standard. Also, the selection can be restricted to the actual needs. This means the number of use time steps or the third dimension can be set. Moreover, the picture quality can be changed by modifying the resolution. When exporting window contents as datasets, there are several options available. Region specifies the selected area scope. A limitation can derive from the zooming function or dimension reducing. Geometry specifies the file size with the unit cells in grid cells. When exporting group as image, only the image solution and not the content itself is changed. When selecting anything else but current. Background and foreground color change the background and text color of the exported image. This section deals with the arrangement of the windows, which are active datasets opened as one group by dp-micress. Tile arrangement refers to the field in which an active dataset can be revealed. So dp-micress makes use of a grid layout. This grid size can be varied by the tile arrangement tool. Either width or height are varied. This means that if the columns are set as 2, one dataset is presented in a way that a second dataset could fit into a second column next to it. The opposite is happening when fixing the rows as 2. Then there would be sufficient space for a second row under the other dataset. Arranging windows by the Tile Windows tool affects the layout of the result files. The datasets are organized in a way that the available space is fully utilized and consequently the background is avoided. Then Cascade Windows is useful when dealing with several datasets. This means that if we have 2 datasets in one group, then by cascading the windows, they are presented in a way that the active datasets are ordered and the files titles can be seen here. But only one dataset can be seen completely as top window. There are 3 possibilities for setting the window size. First of all, set window sizes enables a manual input in width and height in the unit pixel. This function is only applied on one dataset separately. Secondly, there is fit window sizes, which automatically takes the geometric form of a dataset into account by adjusting the appropriate format. Thirdly, fit main window size modifies the size of the Micress main window in a way to make the currently active group as clearly visible as possible. Duplicate all windows creates an exact copy of the dataset's current timestamp and in general of the current settings in the same group. The rubric content changes the perspective from which the simulation is observed. Moreover, it enables the manipulation of several parameters. For example, the 3D tool. Based on all applications is the idea of observing a certain entity in the dataset, so moving between valid values depending on the dataset itself, where every number is a layer of a cross-section is enabled. So the dimension can be chosen and a specific layer is revealed. When selecting cutting plane up or cutting plane down, a scrolling through several layers is done. Repetition and mirroring refers on one chosen active dataset and duplicates the dataset in a specific manner. So firstly, there has to be decided whether this tool is applied horizontally or vertically. There are the same options available for horizontal and vertical operations. So by choosing the repetition function, the dataset can be repeated by stringing the files together twice or 3 times. The mirroring tool works alike. The same dataset is mirrored in a series twice or 3 times. The form of expression can be revised by pressing the disabled button. Principally, the zoom tool serves the same purpose as the zooming tool by opening a rectangle. It just differs from the rectangle zooming in the manual setting. The unit of reference are cells, and when zooming, the rest of the dataset is normally cut. If there is still space for the cut area after zooming, this area is kept on showing until the Hide Outside Data Points field is activated. By clicking on the Properties rubric, statistical characteristics are pointed out, such as window. Here, the dataset about which statistical information are given is defined. So if there is a group containing several datasets, one can be picked. Another parameter is region. There, the visible area of interest is chosen. In the case of zooming, there is no difference in the image section, because the currently visible region will tally with the zooming region. Furthermore, with time steps and display mode, it is possible to choose whether the actual time steps or all time steps shall be selected. Consequently, a window is popping up, revealing a visualization as graph or table. Exporting the results as a table is only possible when visualizing the graph beforehand and not the table. The application ratio gives the ratio of width and height, so it is possible to set this ratio in a different way by entering the data according to an adequate presentation. Isolines refer on areas in which the same values prevail. So in DP Micress, they reveal, for example, consistent concentration values. Here, the number of lines, their color, and their width can be varied. The Annotations tool contains color scale options. Here, the color scale can be shown or hidden. Furthermore, the colors in which the color scale is presented can be changed. And by clicking on Position, it can be moved to a fixed position on the top, to the left or right, or on the bottom. Independent stands for the moving of the color scale to a separately variable dataset. Flip scale defines whether the coordination system scale is located on the right or on the left of the color scale itself. The distance between color scale and window boundary can be varied by using the tool Set Gap. By clicking on Set Range, the color scale spectrum with minimum and maximum values can be chosen. And by clicking on Set Size, the color scale can be widened or narrowed. Concerning the length scale, there are 4 options available. By using the tool Show and Hide Annotation, can be chosen whether the length scale is revealed or not. This annotation can be horizontally or vertically arranged. By clicking on Set Size, there is the option of selecting a different scale, so the observable file segment itself stays the same, only the length scale's extension is varied. So firstly, the length of the length scale itself can be changed. And then a suitable unit can be chosen. Secondly, the width of the length scale can be varied. So here, the area of the length scale has gotten bigger. The information box generates or hides the data file's properties and their status. Show Hide Annotation again hides the information on a certain data file. Then the information box can be located on the right, top, left, or bottom of the data file. Set Content means that the information line, which will be displayed in the information box, can be edited. So there are several keywords available. For example, $W for the current window name, which is removed. Set Size can, analogously to the length scale options, reduce or enlarge the field in which the information are provided. In the rubric information box, there is the possibility to show or hide the Micress logo in the lower right corner. The animation tool has the same application as described for the quick start bar. So it is just another way of dealing with different time steps. The rubric Options deals with 2 categories: Edit Settings and Restore Default Settings. Edit Settings, again, has 3 subordinated categories: Appearance, Memory, and Miscellaneous. There are several basic settings selectable.
Firstly, in appearance, the font, its size, and the window colors of the DP Micress layout can be chosen. Secondly, memory contains important features providing smooth operation. Maximum memory usage for time-step caching limits the amount of memory which will be used for caching time steps in main memory, which are shown before. This parameter allows to control the granularity of the time-step cache. It depends on the size of the data, which percentage of cache memory is a useful setting. Temporarily uncompressed files, which are larger than MB. For large compressed data files, it is more efficient to uncompress them once before showing them. All following read options will access the uncompressed file and will be faster.
Miscellaneous hides and confirms confirmation dialogues, and the tool timer hotkey chain is retained means that if a part of a hotkey is entered, it can be completed within 2 seconds. The tool time between frames in animation refers on making a video out of the simulation, and when filming the ongoing simulation, the time space between 2 simulation steps is fixed.
The rubric Help offers 2 ways to achieve further information about Display Micress. The category DP Micress Handbook is a direct link to the Micress website, where you can find the DP Micress Handbook, amongst other things. Summing up the basic introduction, which was presented in this video, one can say that from now on, we know how to work with the applications of the Quick Start bar and the taskbar. The next video, DP Micress Analyzing Results, will deal with the analyzing of points, lines, and angles. Some tools in the rubric Content were left out here and will be part of video 4, Micress Advanced. The rubric Virtual EDX, Grouping, and Scripting, which were also left out in this video, will also be treated in video number 4.